network configuration and traffic management, assigning IP addresses, static addressing. Overview involves assigning a permanent IP address to a device, akin to a fixed home address for consistent and long-term identification. Dynamic addressing description utilizes DHCP, Dynamic Host Configuration Protocol, for assigning an IP address to a device temporarily, much like assigning a changing hotel room number to each guest. Boot protocol, boot P. Functionality: an older protocol that aids a computer in locating its IP address and other necessary network information upon startup. Automatic private IP addressing analogy: similar to a ship navigating by stars in the absence of a compass. This method involves a device assigning itself an IP address when a DHCP server is not available. Identifying MAC addresses. Explanation: a MAC media access control address serves as a unique identifier for network interfaces, similar to a serial number for a device's network card, crucial for local network activities. NAT and PAT address translation methods. NAT network address translation analogy: NAT functions like the receptionist of a large office, directing calls data packets to the appropriate department device. It translates private IP addresses into a public one for external communication. PAT port address translation description: PAT extends NAT's capabilities by managing specific ports, analogous to handling extensions in an office's internal phone system. As NAT source NAT and DNAT destination NATs variations, these are specialized forms of NAT, dealing with the source and destination of network traffic, respectively. Routing and switching management. The default gateway role, previously explained as the primary exit point from a local network to broader networks. Routing tables. Function: act like a city map for network packets, providing directions to reach their intended destinations. Static routing concept involves setting predetermined routes for network traffic, similar to establishing a permanent path through a forest. Default route usage: the fallback path network traffic takes if no specific route is available for a destination. Switching methods. Approaches: various methods switches use to send frames across the network, such as store and forward or cut-through techniques. Packet and circuit switching. Packet switching process involves sending data in small units called packets over a network, where packets can travel via different paths, akin to cars taking various routes to avoid traffic congestion. Circuit switching method establishes a dedicated pathway between 2 points for the duration of a connection, much like creating a private road for a specific journey. Comparing switching methods. Analysis involves evaluating packet and circuit switching based on efficiency, reliability, and scalability, similar to comparing different transportation methods for speed and cost effectiveness. This structured format provides a comprehensive understanding of the processes and methodologies involved in network configuration and traffic management. Network engineer training. Network configuration and traffic management are integral components of ensuring smooth, efficient, and secure network operations. Understanding and implementing various aspects of these processes are crucial for network stability and performance. Network configuration aspects: assigning IP addresses. Static addressing involves assigning a fixed IP address to a device, providing consistent and long-term network identification. Dynamic addressing utilizes DHCP for assigning IP addresses temporarily, enhancing flexibility and efficient address utilization. Boot protocol BootP, an older protocol aiding in network booting and IP address assignment. Automatic private IP addressing APIPA enables a device to assign itself an IP address in the absence of a DHCP server. Identifying MAC addresses. Every network interface has a unique MAC address, serving as a permanent identifier for the device's network card, crucial for directing local network traffic. Traffic management techniques. NAT and PAT address translation methods. NAT network address translation works like an intermediary, translating private IP addresses into a public one for external communications, ensuring security and efficient address utilization. PAT port address translation extends NAT capabilities by managing specific ports, allowing multiple devices to share a single public IP address. SNAT and DNAT, specialized forms of NAT that handle the source and destination of network traffic, respectively. Routing and switching management. The default gateway acts as the primary exit point from a local network to broader networks. Routing tables provide directions for network packets to reach their destinations, similar to a city map. Static routing involves setting predetermined routes for network traffic. Default route serves as a fallback path for network traffic when no specific route is available. Switching methods. Packet switching sends data and packets over the network, allowing for diverse paths and efficient utilization of network resources. Circuit switching establishes a dedicated pathway between 2 points for the duration of a connection, ensuring a consistent and uninterrupted flow. Comparing switching methods involves evaluating packet and circuit switching based on efficiency, reliability, and scalability. Importance of network configuration and traffic management. Proper network configuration and traffic management are essential for maintaining network integrity, performance, and security. Assigning IP addresses correctly ensures that devices can communicate effectively, while MAC addresses play a crucial role in directing traffic at the local network level. NAT and PAT are vital for conserving IP addresses and protecting internal networks, whereas routing and switching techniques dictate how data is moved across networks. Together, these components contribute to a robust and dynamic network infrastructure capable of adapting to varying demands and ensuring continuous, secure communication. For network professionals, understanding and effectively implementing these aspects is crucial for optimizing network performance and reliability.